our last two pages, still in section 1.5, we're talking about something very similar to what we did with segments again. Yesterday, we talked about angle addition postulate, and previously in the chapter, we had talked about segment addition postulate, where you're just adding up the two parts to make the whole for the segment. Same idea, adding up the two small angles to make the big angle. And so we had some similarities there. We're also going to have some similarities in talking about the fact that not only can you have congruent segments, you can also have congruent angles. Congruent means having the same measure, being essentially equal in measure. Visually, it looks a little different for angles than it did with segments, though. With segments, when you had two segments that were congruent, you had these little things on them. Notice tick marks. With angles, we have angle marks, but I can't draw just a little tick there, because if I drew a tick, then it would be talking about the segment. Visually, angles that are congruent, inside the angle, they've got like this little arc going from one ray to the other ray, indicating that those are congruent. Now, when it comes to talking about congruency, when it came to segments, like let's say this is AB and this is CD, there was different symbolisms for equal versus congruent. Equal signs had no bar above, while congruent symbols, which was the equal sign with a little squiggle above it, did have the bar above. Essentially, a congruent symbol, you put that in between the names of things, while equal signs you put between their measurements. Now, we've already talked a little bit about having equal signs with angles versus having versus just talking about their names. If you use an equal sign with an angle, you have to put the little m in front of the angle symbol. Measure of angle A equals measure of angle B. And you could still use three-letter names. This picture just only has the letters on the vertex, so we can use the single names because those are the only angles with A as a vertex and with B as a vertex individually. While congruent symbols do not have the little m's. It's just the angle's name. So angle A is congruent to angle B. Now, much like when we talked about with segments as well, with segments you had what was known as a midpoint if you had two congruent segments next to one another making a bigger segment. And you also had a segment bisector which went through that midpoint. Similar, we can also have what are known as angle bisectors. Which an angle bisector is a ray that divides an angle into two angles that are congruent. So I've got this angle right here, and if I draw a ray going smack dab through the middle of them, such that this angle and this angle are congruent. Now note, when I put congruent angles right next to one another, I tend to do the little archy things not quite at the same depth. I do that just so it's really easy to see that that's two separate arcs. But if I draw this in such that those are congruent, that ray right there is the angle bisector. Now I'm going to put some points on this picture. That's point A. The vertex is point B. Over here I've got point C, and then on the angle bisector I'm going to put point D. You good? Trying to tighten it. if we see a picture like this, we would say BD, the ray, bisects angle ABC. Now, when we talked about segment bisector, you'll notice that the way that it's written is very, very similar. It had something, bisects, and then it had the thing that got bisected. And it's important to know that because the difference between how you notate an angle bisector versus a segment bisector is just the second thing. This is the thing that got bisected. This is the thing that got cut into two congruent angles. While the first thing is still the bisector. It's the thing that did the cutting. It's essentially the knife. That is good to note because once we finished this, for example, when we get into tomorrow's review, when we get into the test that is coming up Friday, actually more so when we get into chapter 2, you're going to see the word bisects and you're going to have to be able to recognize is it a segment bisector or an angle bisector. Always look at the second thing. Is the second thing a segment or an angle? In this case, it's an angle, hence it was an angle bisector. Back on page 9 where we had it, this was a segment, therefore it was a segment bisector. Okay, so you're going to see some instructions today that say things like this. If TR bisects angle STU and the measure of angle STR equals 28 degrees, find the measure of angle STU. So, with this, generally speaking, you're going to want to draw yourself a picture. TR is the bisector. That's the thing that goes through the middle of the angle. And I gave you an angle to start with to make it easier. I'm going to draw in my bisector. That bisector is TR. It is a ray, which means where it starts, which happens to be right here, has to be T, and then somewhere along it is R. I also should know that these are congruent because it says bisect. Bisect means two congruent parts. Okay, it's angle STU that got bisected, which means this angle was angle STU. T is already on the vertex, which is good. On one of the rays, I'm going to have an S. On the other ray, I've got a U. And it's a little hard to tell, but there actually were dots there already. So that picture is going to give a lot of information because sometimes they're going to give different things about the picture. In this case, they gave me the measure of angle STR. STR is this part right here. And they said it was 28 degrees. I'm looking for the measure of angle STU. STU is the big one? How can we find it? STU is the big one. Here's the thing about that I know about STU is it's got two congruent parts. So if that's 28 degrees, what's this? 28 degrees. And if both of those are 28 degrees, how can I get the big one? Add them together. That's angle addition postulate at work. So the measure of angle STU is equal to the 28 plus the 28. And 28 plus 28 is? 56 degrees. Sometimes they might give you the big angle and ask for one of the little ones. If you know the big one, the little ones, when it's a bisector, are half of it. Okay, more often you're going to see some variables involved. BE bisects angle FBD. So I got this angle that I drew out already. I'm going to draw a bisector. So I'm going to try to go directly through the middle as best as possible, making that congruent to that. That bisector was BE, which means what's this point got to be? B. Where's E got to be? Somewhere on the bisector, somewhere on this ray. It doesn't matter where, other than not right there. E. Okay, the angle that got cut in half was angle FBD. Now I've got a point over here and I've got a point over here. Those 2 points better have what as their letters? F and D. Does it matter which one goes on which? No, it's still angle FBD regardless of which one is the F and which one's the D. Okay, measure of angle FBE. Angle on the right, angle on the left, or the big one is FBE. One on the left, 4x plus 16. And the measure of EBD, right one or big one? That's the right, EBD is 6x plus 4. Find the measure of angle FBD. Okay. Yesterday we had pictures that looked like this. Thought we had one more thing about them. We had the 2 parts and we had the whole, and we could say the smaller angle plus the smaller angle made the bigger angle, but we don't know anything about the big angle here, so we can't do that. But what we do have is these markings that bisect gave us. Those markings tell us those 2 angles are the same, congruent, equal. Therefore, we can set 4x plus 16 equal to 6x plus 4. If you do not have those markings on there, then it doesn't mean they're equal and you can't do this. Bisect told us to put those markings and therefore we could do it. But you have to be careful because problems like yesterday, this looks a lot like it, but those 2 were not equal. There's nothing that told us they were equal. There's no word bisect, and there's no congruency marks. Okay, we solve for x. First thing I should do is what in order to solve for x? Can't call on someone who's not here. Cam, how do I start solving for x in this equation?
Minus 16 or 4 something.
Generally, we would start with the 4x. You could start with the subtracting of the 16. I like putting x's together first, and there's a reason for that. It's going to make life a lot easier on some equations. 16 equals 2x plus 4. Diego, what comes next?
What? Which one?
This is our equation. What do I do next to solve?
Minus the 4.
Subtract the 4. 12 equals 2x. Kylie, if I'm solving for x, how do I finish that? And what do we get? And that question was for anyone. What do we get? 6. 6 is equal to x, also known as x is equal to 6. Is that what we were told to solve for? No. We were told to solve for the measure of angle FBD. Now, FBD is the big one. Do we have an expression for FBD? No, we have an expression for the 2 small ones. Can I plug back into one or both of the small ones? Just need to do one. I could plug back into both, but should I get the same thing for them if they're congruent? Yeah. If I don't get the same thing, that's an indication that something's wrong. But I don't have to plug back into both. I'm going to plug into FBE just because I saw it first. It's 4x plus 16. 4 times 6 plus 16 happens to be 40. Yep. Measure of FBD is therefore 40 plus 40, which is 80. I made that angle a little too big. And you're going to notice I always go back and do that formal notation, that measure of angle FBD. Okay, we got 2 more problems. Not all of the problems look the exact same. So just as a heads up, these ones are going to be possibly a little bit different. One of the things you'll probably notice is I didn't give you the starting angle. But is an angle a hard thing to draw?
No.
No. DP bisects FDE. The moment I see those words, I see it's an angle bisector. I draw an angle. I draw a bisector. I know it's a bisector because these 2 things are congruent. What letter goes here? Gesundheit. D has to go here. It's the start of the bisector. It's also the middle letter in the angle name. Going right here is what letter goes here? P. The other ones are F and E. Gesundheit. I always draw my picture first. It gives me structure of where to put things. Okay. Measure of angle FDP is 2x plus 7. FDP, top small one, bottom small one, or the big one? Top small one. Measure of angle FDE is 6x plus 6. Bottom small one or the big one?
Bottom small? No, big one.
Big one. FDE is the big one. If I have one of the small ones and the big one, are those 2 equal this time?
No.
No.
Can we just do 2x plus 7 equals 2x plus 7? Or no, 2x plus 7 plus 2x plus 7 equals 6x plus 6.
Yes. If this is 2x plus 7, though, that means this one is also 2x plus 7. And then I can do angle addition postulate, like we did yesterday, where we add up the 2 small angles, which were FDP and PDE, to make the big one. Now, do you have to write out this equation every single time?
No.
No. Is it going to be an important part of step or chapter 2, which is why I keep doing it? Yeah, that's why I keep doing it. 2x plus 7 plus 2x plus 7 equals 6x plus 6, just as Nate pointed out. We can do that. Because if these 2 are congruent, they're equal. And if I know one, I can call the other one the same thing. At this point, I need to simplify. Because on this side, I've got things that go together. Ava, what goes together? Giving me 4x. Aaliyah? 7 and 7 go together also. Yep. I'm seeing you. 14. Good. Jackson, if I want to solve, what am I going to do first?
Subtract 4x.
You got it. That goes away. 14 equals 6x minus 4x happens to be 2x. Brody. If I wanna solve this, what am I gonna do next?
Subtract 6.
And then we divide by 2 and we get 4 is equal to x, also known as x is equal to 4. Is that what we're supposed to solve for? No. Find the measure of angle FDE. Do we have an expression for FDE though? Yes, this time we do. FDE we knew to be 6x plus 6. So 6 times 4 plus 6 is 30. At this point, I'm going to do similar to what we did yesterday. Try out the last problem on your own. Once you have that done, I'm going to be going around and checking people's answers and giving you the homework assignment. I don't actually know the answer yet. I'm going to finish that problem so it's in the recording.
I have a question.
Give me a minute. I'm trying to finish up this problem so that it's in the video for the people who aren't here.
How do you sift this? Or do you just do like this?
So let's start by drawing a picture. Draw me an angle with a bisector.